Every alternator manufactured or repaired should undergo a voltage regulation test before being delivered to the customer. As we all know, maintaining voltage regulation below 5% is crucial to ensure that the alternator performs with maximum efficiency. The EMF method or synchronous impedance method is the first indirect method used for determining the voltage regulation of an alternator without having to connect an actual load to it. This video will help you to explain the procedure to calculate the voltage regulation of an alternator using EMF or synchronous impedance method. Discuss the advantages of the synchronous impedance method. Identify the limitation of the synchronous impedance method. To calculate the voltage regulation of an alternator using the EMF method, we should determine the per-phase armature resistance, open circuit characteristics, and short circuit characteristics of that alternator. We can calculate the per-phase resistance of the alternator using the ammeter-voltmeter method. Watch our video, Determination of Armature Resistance, to understand how to calculate the per-phase resistance of the alternator. Now, conduct open circuit and short circuit tests on the alternator and tabulate the readings. Then, take a graph sheet and mark the x-axis to represent the field current IF. Mark two y-axes in the graph. One will represent the open circuit voltage VOC, and the other will represent the short circuit current ISC. Plot the open circuit voltage VOC obtained from the open circuit test against the field current IF. Now, connect these plotted points smoothly. This curve represents the open circuit characteristics of the alternator. Next, plot the short circuit current ISC obtained from the short circuit test against the field current IF. Connect these plotted points using a scale. This straight line represents the short circuit characteristics of the alternator. Now, determine the rated current of the alternator from its nameplate details and locate it on the short circuit current axis. Draw a horizontal line from that point to intersect the short circuit characteristics. You can name this intersecting point, say, A. Draw a vertical line from point A to the x-axis and OCC. This vertical line will intersect the open circuit characteristics at point B. Now, draw a horizontal line from point B to the y-axis, which represents the open circuit voltage VOC per phase. The point at which this horizontal line meets the open circuit voltage axis is the value of VOC per phase at the field current that gives the rated current. Divide the open circuit voltage by the short circuit current for the same field current to determine the synchronous impedance ZS of the alternator. Also, we can calculate the synchronous impedance by using the formula shown on the screen. Rearrange this formula and substitute the values of ZS and RA to determine the value of synchronous reactance XS of the alternator. We know that the formula to calculate the voltage regulation is induced EMF EPH at the armature winding minus rated terminal voltage VPH divided by the VPH. Here, we know the value of VPH and we should determine the value of EPH. The formula to calculate the EPH is shown on the screen. By substituting the value of each parameter in the formula for different power factors, you can get the respective values of EPH. By substituting the EPH values in the voltage regulation formula, you can get the voltage regulation values of the alternator under different power factor conditions. Since we are calculating the synchronous impedance of the alternator, ZS, from the graph, the EMF method is also called the synchronous impedance method. In this method, we can determine the synchronous impedance value for any load condition without connecting the actual load to the alternator. So, we can calculate the regulation of the alternator for any load condition. This is the main advantage of the EMF method. But, the challenge in the EMF method is the calculated ZS value is not accurate. It is higher than the actual value. Why? Watch our video, Limitation of EMF Method, to understand the reason for high impedance value and how it impacts the voltage regulation value. We have come to the end of this video. In this video, we learned that to determine the voltage regulation using the EMF method, we need the per-phase armature resistance of the alternator, open circuit, and short circuit characteristics of the alternator. The open circuit voltage divided by the short circuit current for the same field current is the formula to determine the synchronous impedance ZS of the alternator. Voltage regulation of the alternator at any load condition can be determined using the EMF method. The impedance value calculated using the EMF method is higher than the actual value.